So we are here looking at the January 2017 Algebra 1 regions. We're going to start with question number 1. It says, which expression is equivalent to all this over here, 16x squared minus 36? There's a couple ways to do it, and we're going to explore those different ways. The easiest way to do it, and this does not require a calculator, just knowledge of math, is to factor it by hand. You're going to notice maybe I could divide something out over here. Let's try to do, right? Anytime you're factoring, you should really follow the order of starting with trying to Gcf factor. That's the first thing you're going to try to do. So I do see a GCF I can divide out of both of these. I could try dividing 2 out of both of these, right? 16 can be divided by 2, 36 can be divided by 2. Even better than that, though, I think 4 is going to be our best thing to divide out. And you see a 4 in these answers, that's a pretty good clue to say maybe that's the right direction. So I'll start out by doing this GCF factoring. I've got 16x squared minus 36. I'm going to divide a 4 out from both of these. GCF factoring is just the opposite of distribution. Now I cannot divide out an x because the 36 doesn't have an x to give me. So I'll divide a 4 out. And when I do that, 16 divided by 4 will give me 4x squared, right? The x squared is still there. 36, I divide the 4 out. It's going to give me minus 9. So that's the first type of factoring you do, is to GCF factor. I had a greatest common factor shared. I divided it out. Next, I can still keep factoring this, right? This is not an answer that's available 1, 2, 3, or 4. I notice here I've got two terms, 4x squared and minus 9. They're subtracting from each other, and everything here is still a perfect square. 4x squared and 9 are all perfect squares. So that goes to our second method for factoring, which is difference of perfect squares. If you know you're factoring, that's the second one you should always try out. If I've got two terms, they're subtracting, and everything is perfect squares, I can do that. The way you do difference of perfect squares is you just get the square root of each of your terms, and then you add them and you subtract them. So first I'm going to take this 4 down. The square root of 4x squared is going to be 2x. The square root of 4 is 2. Square root of x squared is x. The square root of 9 is 3. And now that I've got the two square roots for difference of perfect squares, I just add them first, and then I subtract them. The 4 was from the GCF that I took out, and then I difference of perfect squares. This should be my answer, and let's see if we can find it. That is answer choice plus 3 minus 3. Looks like it is answer choice 2. Now, I told you there was a different way we could figure it out. The second way to find it is not quite as fast, but it works without needing to know anything. That is, if you have a TiNspire calculator, which we've got right over here. If I've got a TiNspire calculator, there's a nice thing you can do here. I'm going to go home, make a new document, not save, and I'm going to add a graph over here. If I want to compare two different functions, I can just try plugging this in as a graph, and then try each of these different answers and see if it gives me the same thing. So I'm going to start by plugging in 16x squared minus 36. 16x squared minus 36. I graph it, and luckily I see something on the picture. If I wouldn't see anything on the picture, I could always hit Control T to get a table of values. And now all I got to do is just try the different answers. So I graphed, oh man, I've got too many mouses. One on the computer, one on the calculator. I graphed 16x squared minus 36. So let's try answer choice 1, which we know is going to be wrong, but let's try it. 4, 2x minus 3, 2x minus 3. So I'll hit tab, and I'll try graphing 4, parentheses 2x minus 3, parentheses 2x minus 3. If I try graphing that, notice it made this red one. It's not equivalent. If it was equivalent, it would be right on top of the original graph that I made. But it's not. It made a separate red graph over here, right? I'm looking for something that's the same. So if it's equivalent, if it's the same, it should have graphed the exact same thing. So I guess it's not that. Let's try answer choice 2, which is 2x plus 3, 2x minus 3. So I'll hit tab, come back here, and I'll just switch this to 2x plus 3 instead of 2x minus 3. Plus, and if I graph that, you should notice the new graph that shows up You should have noticed a change in the color. It was blue before, it's red now because it graphed exactly on top of my original function. If I hit Control T, I can just confirm that more. For my blue function up over here, at 1, it was negative 20. For the red function I made, it was also negative 20. At 2, they match perfectly. At 3, they match perfectly. I found my equivalent answer. If that wasn't answer choice 2, I would have just kept plugging in for 3 and then 4 until I found a table situation that worked like this, or a graph where it lied right on top of each other. Either way, you've seen 2 ways to solve question number 1. The answer is answer choice 2.